Okay, hi guys. I'm back. I'm gonna do day 4 notes today, and I'm gonna show you some more calculations. So this unit entirely is calculations. So today, this is what would have been on the board in class. It is chemical quantities, volume conversions with moles. And so after today, you're going to calculate the volume of a gas at standard temperature pressure, or STP, given the number of moles, and vice versa. So you're going to perform equations again. It's more follow the units. Okay, so here's a little new bunk bed, or a new conversion factor. For 1 mole, any gas at STP is standard temperature pressure. So that's a number, standard temperature pressure of a gas. The volume occupied by that gas is 22.4 liters. So this is a conversion factor for all gas. So 1 mole of gas, any gas, oxygen, nitrogen, hydrogen, doesn't matter, is equal to 22.4 liters of gas, whatever gas that is. A mole of oxygen gas is 22.4 liters of oxygen gas, okay? So this is a new conversion factor. We're going to write it on our cheat sheet. 1 mole is equal to 22.4 liters of gas at STP, okay? So I actually have, just a second here, I've got a better cheat sheet. So I actually have a typed up version of this. I don't know, can you guys see that? I can hold it up. Okay, so I have a typed up version of this. You can pause the video and write this down. Can you see it? Oof. I'm also going to attach this. Okay, I'm actually also going to attach this to our files, like kind of where the periodic table and stuff is, so you can see it. So this first line says molar mass of a compound in grams from the periodic table is equal to 1 mole of that compound. So we knew that one. That's how we find the molar mass. And then we have these ones. 1 mole is 6.02 times 10 to the 23 atoms. 1 mole is 6.02 times 10 to the 23 molecules. 1 mole is 6.02 times 10 to the 23 formula units. 1 mole is 6.02 times 10 to the 23 donuts. It doesn't matter what we're talking about. It's the same as saying a dozen rolls is 12, a dozen hot dogs is 12, a dozen ducks is 12. It's the same thing. A dozen means 12. A mole means 6.02 times 10 to the 23. Whatever unit comes after it, okay? And then the last one we just added right now, today, is 1 mole is equal to 22.4 liters of gas at STP, standard temperature pressure. So I'm going to get pause and write these down, or print it or look at it when I add it to the sheet. I'm going to add it to over by the periodic table and stuff today. Okay, I'm going to add this. I'm going to call this the mole cheat sheet. Okay, this is called the mole cheat sheet. You would have gotten this on tests and exams. All right, so now I've got it typed up for you, so it's a little easier than this one. It's the same as this that I had you write down. Maybe you were writing down before, but I typed it, so it's just a little bit prettier for you. Okay? Okay. So today we learned a new one. 1 mole is 22.4 liters of gas. Let's look at an example, okay? We're going to look at an example of how this works. So I'm going to do this bigger on paper like I normally do. Okay, so the example question in the notes is, how many moles of helium gas will occupy a volume of 149.3 liters at standard temperature pressure, STP. So that's the question that's on the slide. All right, what do I do? What's my known? What's my unknown? What are my conversion factors? My bunk bed pairs, whatever you'd like to call it. All right, well, I know my known is 149.3 liters because it gave me that. So I have 149.3 liters of helium. Okay? Agree with that? That's what the question told me. My unknown, or what I'm looking for, is how many moles. Moles of helium. That's what it's asking me. All right. What do I always do? How do I always start my problems? I write down my known and put it over 1. 149.3 liters of helium over 1. So now I'm going to build my bunk bed, or if you like to do it this way, it doesn't matter. What is the next pair? Well, I'm trying to get from liters, that's the unit here, to moles. Well, do I have any conversion factors like that? I do now. It's today's new one, moles to liters. So I'm going to write the conversion factor down here. 1 mole is equal to 22.4 liters of gas. That's today's bunk bed. So what am I going to put on the bottom? Well, liters is on the top, so I have to put liters on the bottom to get rid of it. 22.4 liters of helium. Same as the bunk bed. I'm showing you just 2 different ways to do it because not everyone likes a bunk bed. What always goes on the top? What's the bunk bed pair? You're not allowed to change the bunk bed mate. You have to put the pair down. Well, 1 mole goes on the top. We have it right here. 1 mole of helium. Sorry, I'm a messy writer today. 1 mole of helium. So now we've got, it's the exact same thing. Some people like a bunk bed. Some people like it written like this. I'm just doing it both ways. So then we just do the math. Let me find my trusty calculator. My favorite calculator I've had since I was your age. That's how old this thing is. Okay, so I get to go 149.3 times 1, which I'm not going to bother. And the bottom, this side is 1. So now I just have to say divided by 22.4. So what do I get? 6.66. I got to cross out liters of helium. Sorry, I skipped that part. Liters of helium got to go away. So the only unit left is moles of helium. Moles of helium. That's my answer. 6.66 moles of helium. And when I look at the example from the board that would have been up on the board, it's 6.665. It doesn't matter. The significant digits are fine. Moles of helium. So we're right. So that's a new way to incorporate a brand new bunk bed pair or conversion factor. We're talking about liters today. All right, I'm going to teach you the next little section here. So let me flip my paper. Okay, it says here, we've already learned how to convert moles into other particles. We know 1 mole is 6.02 times 10 to the 23 atoms, molecules, formula units. We know how to do that. We also know how to do 1 mole is the atomic mass or the molar mass in grams. We know how to do that. And we know that 1 mole is 22.4 liters. Basically, this little box right here is saying the same stuff that I had typed out for you. Okay? It's just giving you all the bunk bed pairs or all the conversion factors. Here's a little drawing. This is in your notes. You might like this. It looks like a kind of like a fidget spinner. Okay? Like how you get mold, particles to mass. Maybe this little diagram will work for you, or maybe just the cheat sheet that I typed. It's up to you. This is just a visual representation of how we can go back and forth out of things to get to a mole. Okay? This is all in the slides. All right, they're going to ask us another question here. And this is what I'm going to do here. So the last little bit here, they've asked us another question. I'll write it down and do it out so you guys can see me. Okay, the question is, what volume would 4.32 times 10 to the 23 atoms of krypton gas occupy at standard temperature pressure? That was the question. All I did was write it down from the slide. Okay, just wrote the question over here. So let's look at this. What do I do? Well, I can see right now I have a known and an unknown. So let's just write those down. My known is 4.32 times 10 to the 23 atoms. They told me that in the question. And it's asking what volume. So my unknown is volume, which will be in liters. of krypton. And this is of krypton. Okay, I think krypton's KR. Let's just double check. And yeah. So I'm just going to represent krypton with KR from now on because it's easier to write. Okay, all right. So that's our unknowns. So now I got to look at conversion factors. What bunk bed pairs or conversion factors am I going to use to do this? Well, where do I start? I always start with the known and put it over 1. So 4.32 times 10 to the 23 atoms of krypton over 1. I like to make bunk beds. You can do it the other way if you'd like. What bunk bed pair is coming next? Well, I'm going to take my little typed up cheat sheet this time and say what I'm really trying to do is get from atoms to liters. That's what it's asking me. Is there anywhere that I have atoms to liters? Well, I see atoms here. It goes to moles. And I see moles to liters, but I don't see atoms to liters. So that means it's a two-stepper. I have to go atoms to moles and then moles to liters. So the two conversion factors we're going to use is 1 mole is equal to 6.02 times 10 to the 23 atoms. That's one of our conversion factors. And then the other one is 1 mole is equal to 22.4 liters of gas. That's our second bunk bed pair or conversion factor. Now I can see a relationship between moles and liters, but I've got to go through, atoms and liters, but I've got to go through moles first. All right, so this is a double bunk bed because there isn't any way I can get to where I want to go with 1 bunk. Atoms are on the top, so what has to go on the bottom? I'm trying to cancel atoms. The unit with atoms. So 6.02 times 10 to the 23 atoms. And today we're talking about krypton. Goes on the bottom. What has to go on the top bunk? Because they're a bunk bed pair and I can never, ever, ever change it out. 1 mole. And today we're talking about krypton. All right. That's a good start. I got to cancel atoms of krypton, atoms of krypton. They top and bottom go away. Just leave the numbers. We'll deal with those later. So now I've got a mole. Well, my question asked me for a volume, liters. So I already used this one. So now I got to use this conversion factor. Well, what goes on the bottom? I want to get rid of moles of krypton. So the mole has to go on the bottom. 1 mole of krypton is equal to, top bunk has to be this pair, 22.4 liters of krypton gas. You could say gas, or krypton is a gas, so that's okay. So what got to disappear? Moles of krypton. Moles of krypton. That is awesome. So now I only have 1 unit left, liters of krypton, which is what I was looking for. I let the units tell the story. Okay, I let the units tell the story. So now I have to deal with the numbers. I only have the unit left that I want. Let's show you guys how to do the numbers. Okay, I multiply the top, 4.32 exponent 23 times 1, which I'm not going to bother, times 22.4. And I always hit equals. Then I get a whole number. Now I'm going to divide it by the bottom. Well, this is a 1, so I don't have to do that. And this is a 1, so I don't have to do that. So I only have to do this. Divided by 6.02 exponent 23 gives me a number, 16.07. 16.07. What's my unit left? Liters of krypton. That's my answer. Liters of krypton. I did the math. Let's look at the cheat sheet. 16.1. They rounded up 1 more than us. So we're right. Correct. So this is how, it's not a lot different than what we've been doing, but I just added 1 more bunk bed pair, or 1 more conversion factor to our list. Okay, so now we can do a lot of problems with these, which you'll see. All right, that's it for, I guess that was day 4 in the notes. And so I'll have a few more videos this week on how to do more practice problems with these, and then how to do the next set too. All right, guys, have a good day. Thanks. Bye.